3.1 quadratic functions, better known as our parabolas. This is also known as the squaring function that we talked about in 2.3. Now, in this section, I want you to be able to graph a basic parabola. But in order to graph a basic parabola, you need to be able to give me the vertex, the x-intercept, and the y-intercept. Also, the axis of symmetry, the domain, and the range. First example. F of x equals x plus 3 squared minus 4. Now, this is known as our vertex form, and in this form, you can easily tell me the vertex of the parabola. Now, to remind you, the parabola is known as our u function. The vertex would be that opening point, and mine is not quite centered, but it's that central opening point of your squaring function. So if I'm asking to find the vertex in this form, it's always going to be the opposite of what's in parentheses for the x coordinate. So that would be -3. And your y coordinate is the number that's on the outside. You do not change the sign. The only one you change the sign of is the number that's on the inside of the parentheses. So my vertex will start for the x coordinate the opposite. It's kind of having the same effect as with the circles. When you were giving me the center in 2.2, you gave me the opposite. So the x coordinate would be -3. The y coordinate is on the outside. It stays the same. It will be -4. That's our vertex. Next, let's look at finding the x-intercept. Now, in order to find the x-intercept, you must let y equal 0. Okay? You let y equal 0. So we know f of x means y. And I'm going to just rewrite it so you'll see that f of x is the same as y. In the place of y, I'm going to put 0. And I'm going to solve for x. Now, this takes us back to what we did earlier for test 1. In chapter 1, you have two actual terms. So this will be the square root function. So we're going to do the square root method. So we're going to get x by itself by first adding 4 to the other side. And then we're going to take the square root of both sides. Now, with the square root method, when you do that, you always got to do plus or minus. So that will give me plus or minus 2 equals x plus 3. Now, to get x by itself, you're going to subtract 3. Now, you have x equals -3 plus or minus 2. Now, this is two answers. So, separate it. You have -3 plus 2, which will give -1. And you also have -3 minus 2, which will be -5. So, our parabola is going to cross the x-axis at -1 and also at -5. Okay? That's how we find the x-intercept. All right? Keep in mind that's going to cross the x-axis at -1 and -5. Now I'm going to do a little erasing. And we're going to find the y-intercept. Now, in order to find the y-intercept, this time you're going to let x equal 0. Anytime you're finding intercepts, you let the other variable be 0. So back into our original equation, we know f of x means y. And we said in the place of x, you're going to allow it to be 0, which means it's gone. So technically, you just have 3 squared minus 4. That's 9 minus 4, which is 5. So it's going to cross the y-axis at 5, okay? So we just said that our x-intercepts are -1 and -5. Our y-intercept is +5. Now, I'm going to write all the things that I need to graph over here on the side by my vertex. So I have x-intercept, gonna have a blank for it. Y-intercept, I got a blank for it. Now, when you write them in the blanks, now these blanks, if we were taking a written test, I would have had these blanks where you had to fill them in. On my labs, you're going to have to input this into my labs. So when they ask you to give the x-intercept or the y-intercept, you need to write them as an ordered pair. So we said that it's going to cross at -1 and -5, but we're going to write them as ordered pairs. So that means it will be -1, 0 and -5, 0. Keeping my x-intercept, the x number is going to be where it crosses at. We let y be 0. The y-intercept, we just said it's going to cross at +5. So you need to enter it as an ordered pair. So that would be 0, 5. Okay, keep in mind, these are points. And we're going to plot these 4 points to graph our parabola. Now, the next thing it's going to ask is the axis of symmetry and domain and range. But I would like to plot these 4 points first to show you our actual parabola. So I'm going to switch screens. On our graph, here we go. We're getting ready to plot. Now, that we said the vertex, the central point, is at -3, -4. So on my graph, we know that this is the y-axis and this is the x-axis. I'm going to go to the left 3 lines, 1, 2, and don't make a dot. My pen is very, okay, 1, 2, 3, and go down 4. 1, 2, 3, 4. Okay, that's where our vertex will be at -3, -4. That's our opening point. Now, we also said it's going to cross the x-axis at -1. That would be there. And it's going to cross at -5. That would be there. Now, it's going to cross the y-axis at +5. That would be there. Now, those 4 points should be enough for you to graph a sketch of this parabola. So once you have the x-intercepts plotted, the y-intercept plotted, and your vertex plotted, connect them in the shape of a U. That was a little wobbly. And that would be your parabola. Now, parabolas make a U. So if I wanted to do an axis of symmetry, okay, axis of symmetry, that's going to be the vertical line that would cut this picture in half, okay, the vertical line that would cut it in half. That would have to be a vertical line going through the vertex. And I'm going to do that with a dotted line. You see that vertical line? That vertical line, if I was to draw that line and cut my picture there, it would be symmetric, meaning the left side would be exactly the same as the right side. So that line is going to ask you for an axis of symmetry, okay, as a blank to fill in on my labs. You're going to say that that line's equation is x equals negative 3, okay? I want to know the equation of that vertical line. Now, we know it's going to be x equals negative 3 because it's vertical. So, you know it has to be an x-only line. And we know it's at negative 3 because our vertex, this point right here, is negative 3, negative 4. And the x number of the vertex is negative 3. So my axis of symmetry will always cut on the vertex. So it will always be a vertical line with your x coordinate, okay? Now, looking at this picture is also going to ask you about domain and range. So we have talked about the domain and range back in chapter 2. The domain of all parabolas, because eventually this parabola will continuously grow from left to right. So it will be from negative infinity to positive infinity. The range, this goes up and down. Now, this is only going upward. So the range is going to start wherever your y-coordinate is of your vertex. So it started at negative 4 and it's continuously going up. So we're going to positive infinity. Now you see I put a bracket on my negative 4 because that's a closed-in circle at my vertex. So all that I've given you here on this very first problem, it seems like a lot, but you had to tell me what the vertex was. And we know that it's negative 3, negative 4. You told me that the x-intercepts, they cross at negative 1, 0 and negative 5, 0. And our y-intercept crosses the y-axis at 0, positive 5. And that's what I'm looking for, okay? Example 2. F of x equals x plus 2 squared minus 9. So again, I need to know that vertex. I need to know my center point. So it's going to be the x-coordinate is the opposite of what's in the parentheses. So that's negative 2. And my y-coordinate is whatever number's on the outside. This form, and I want to make sure I say that, is your vertex form. Because you can easily tell me the vertex by looking at it. So we know this is going to start at negative 2, negative 9. Next, we need to know the x-intercepts. I need to know where does this thing cross the x-axis. So we're going to let y equal 0. Okay? Let y be 0. So we know that f of x means y in our problem. So we're going to let it be 0. And again, you have two terms. So if we're looking for x, we're going to do the square root property, which means we're going to move 9 over, make it positive. And then in order to get x by itself, we're going to take the square root of both sides. Anytime you take the square root, that gives you plus or minus. Don't forget that. You got two places it's crossing the x-axis. So you must have plus or minus. Square root of 9 is 3 equals x plus 2. And again, to get x by itself, you're going to subtract 2. And so you got two places where this thing is going to cross the x-axis. So we have negative 2 plus 3, which would give us a positive 1. And we got negative 2 minus 3, which would give a negative 5. So our x-intercepts is going to cross. Now this parabola has two arms. So it's going to cross the x-axis at positive 1 and negative 5. Okay. Now let's find the y-intercept. Y-intercept, this time we're going to let x equal 0. Let x be 0. So back to our equation. It's y equals x plus 2 squared minus 9. And I'm going to let x be 0. So if I let x be 0, it's gone. So we're working with 2 squared minus 9, 4 minus 9, which gives us a negative 5. So this parabola is crossing the y-axis at negative 5. Okay. Now keep in mind that when you're inputting this into my labs, they're going to want you to write your x-intercepts and your y-intercepts as ordered pairs. So we said that it's going to cross the x-axis at 1 and negative 5. So that would be 1 comma 0 and negative 5 comma 0. Because keep in mind that has to be in the x spot. Our y-intercept, we said it's going to cross at negative 5. So that would be 0, negative 5. Keep in mind that has to be in the y spot. So these 4 points are what we're going to plot to draw our actual parabola. The vertex, the x-intercepts, and the y-intercept. So our vertex, let's plot it first. It's at negative 2, negative 9. So I'm going to go over 2 lines to the left. And I'm going to go down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's my vertex. And it's going to cross the x-axis at positive 1 and at negative 5. And it's going to cross the y-axis at negative 5. So I have my 4 dots, and I'm going to connect them. And my hands are really shaky on this iPad. And then I'm going to draw a dotted line to represent my axis of symmetry. And that's going to go straight through that vertex. That dotted line is going to symbolize my axis of symmetry. So on my labs, they're going to ask you for that axis of symmetry, and you're going to write it as the equation of that line, which would be x equals negative 2, because we're going through the vertex, and the x coordinate is negative 2. Okay? Our domain. Now your domain for all of these parabolas is going to be from negative infinity to positive infinity. And then your range is going to be where you started on the y-axis, in which is negative 9, and it's going up. So that would be to positive infinity. And you see I put a bracket on negative 9 because that's a closed-in circle. And we know that this point here was our vertex. and that was negative 2, negative 9. This was our y-intercept. As an ordered pair, that's going to be 0, negative 5. And our two x-intercepts, that's going to be negative 5, 0, and positive 1, 0. Example 3. F of x equals x squared plus 8x plus 7. Now, this is the second form for our parabolas. You had the vertex form, and now you have a general form. It's kind of the same setup with circles. Circles, you had the center radius form, and you also had the general form. This is known as our general form. Okay? So, in the general form, it's a little different on finding our vertex. Now, you can do completing a square to find that vertex, but that method doesn't work as clean as the formula method, okay? So I'm going to show you guys the formula method, and to find that vertex, to find the x coordinate of it, you're going to do minus b over 2a. Minus b over 2a. Now, you need to know what's a and b. Now, this goes all the way back to the quadratic form. When we plug into the quadratic formula, we know this is a, b, and c. All right? So, you're going to say minus your b coefficient, which would be 8, over 2 times the coefficient on a, which we know is an understood 1. The very first number on x squared is a 1. So that's negative 8 divided by 2, which is negative 4. Okay? So our x coordinate of the vertex is negative 4. Now, in order to find the y coordinate, you're going to take negative 4 and plug it in for x, and it's going to produce y. Okay? So we're going to go back to the equation, x squared plus 8x plus 7, and you're going to plug in where x is, we're going to plug in negative 4. And so, we're going to square. That will give us a positive 16. Multiply. 8 times negative 4 is a negative 32. And then we're going to bring down our plus 7. So you have 16 minus 32, which is a negative 16, plus 7, which will give us negative 9. So our vertex, the x coordinate is negative 4, and the y coordinate is negative 9. Okay? So it's a little bit more work than just looking at it and pulling out the x coordinate and the y coordinate. We had to actually do the actual plug-in formula for negative b over 2a. Okay? So we know our vertex is at negative 4, negative 9. Now let's find our intercepts. Now, taking you back, you know this is a quadratic equation, okay? Quadratic equation. So, with that in mind, if I'm looking for my x-intercept, again, we still gonna let y equal 0. So if we let y be 0, this should take you back to what we did very early in the semester. This can be factored, okay? And that's what I'm going to do. I'm going to factor my 2 parentheses. I am adding to get 8. Very simple factor. You only have one factor of 7. 7 and 1. And we're adding, and 8's positive, so they're both positive. Now, since it's set equal to 0, you set each parenthesis to 0 to tell me where it's crossing, which is going to be the opposite. We know it's crossing at -7 and -1. Those would be our x-intercepts. So just factoring it would give me my x-intercepts, okay? It's crossing at -7 and -1. And keep in mind, when we put this into my labs, they want you to write it as an ordered pair. So this ordered pair would be -7, 0, and this one would be -1, 0. The x-coordinate has to carry the number. And remember, you let y be 0. So that's how we find the x-intercept. Y-intercept, you're going to let x equal 0. So if we let x equal 0, in our equation, then can't you see that this is going to be gone? All of this is gone. So you just got y equals 7. It's pretty simple. So that as an ordered pair would be 0, 7. Keep in mind the y has to carry the 7. And you let x be the 0. So we know our x-intercepts, our y-intercept, and our vertex. So now let's graph. Okay, we're going to graph our first point, which is the vertex. We're going to graph it at -4, -9. And then we're going to graph our x-intercepts, crossing the x-axis at -1 and -7. Those are the x-intercepts. Crossing the y-axis at +7. And with our 4 points, we're going to connect. I missed that point. I'm just so off trying to graph. But you get the picture. It should cross. It should hit both of those points. And then I'm going to have my axis of symmetry represented as a dotted line going straight through my vertex. And keep in mind, symmetric means it's the same on both sides. So if I was to cut it, my parabola at that line, it would be symmetric, okay? So, again, what we have here is the vertex is at -4, -9. We know our x-intercepts. The first one is -7, 0. and negative 1, 0. Our y-intercept is at 0, positive 7. And we know our axis of symmetry is x equals negative 4. And our domain for all of the parabolas is negative infinity to positive infinity. And our range is going to start at the y, which would be negative 9 to positive infinity. Okay. Example 4. F of x equals negative x squared minus 6x minus 5. I want to do a negative one because I wanted to show you how to determine if your parabola is going up versus going down, okay? And all of that comes with that negative being in the front, okay? So if that negative is dead in the front, then your parabola is going downward, okay? The other 3 examples I've showed you, they're going upward because the beginning was positive, okay? So keep that in mind that this thing is going to go downward, okay? We're going to find that vertex, and we're going to use for the x minus b over 2a. Keeping in mind this is in quadratic form. Get rid of that so I can have some room. So our b term is as minus the b term, which is a negative 6, over 2 times your a term, which is negative 1. Watch your signs. So that's going to produce a positive 6 divided by a negative 2, which will produce a negative 3. Okay? That's going to be our x coordinate of the vertex. Now to find y of that vertex, you're going to take negative 3 and you're going to plug it in for x. And you see, I like putting it in parentheses. And so, watch your order of operations. If you got a calculator, type this whole sentence in so you won't mess up on your signs. But you're going to do the exponent first. Negative 3 squared is going to give us 9. And then since the negative's on the outside, it will remain negative 9. Negative 6 times negative 3 will give me a positive 18 minus 5. Negative 9 plus 18 is a positive 9. Minus 5 will give me a positive 4. So its vertex, the x coordinate we found to be negative 3, and the y coordinate we found to be positive 4. So that's where we're going to open up at, negative 3, positive 4. Okay. Now let's find my intercepts. X-intercepts, and then we'll look at y-intercept. To find the x-intercept, again, you're going to let y be 0. So if we let y be 0, we know that we're in factor mode. 3 terms, trinomial. Now, to make this easy, Factor off the negative. Treat it like a GCF. You don't want your x squared term to be negative. So it goes against your factoring rules. So, I like to make everything easy. So if everybody's negative and I take a negative away, then everybody is positive. It makes my factoring so much easier. So I am adding to get my 6. Very simple. You don't have a one factor, 5 and 1, both of them positive. Now, this negative on the outside has nothing to do with the inside of this parenthesis. So you just throw it away, disregard it. We know it's going to cross at -5 and -1 because you're going to set each parenthesis to 0. Disregard that negative. That negative has no effect on what's inside the parenthesis. You just strictly take the opposite. So we know that's our x-intercepts, -5 and -1. Okay, let's find our y-intercept, which you can look at it and tell the y-intercept. If you let x be 0, that means this whole side over here is gone, but -5, all that's gone. So we know it's going to cross the y at -5. Okay. And so let's now take those 4 points and plot them. So we know that our vertex is going to be at -3, +4. It's going to cross the x-axis this time at -1, -5. Sorry about that. And it's going to cross the y-axis at -5. So now you see that our vertex point is up because we got to come downward, okay? So now we're going to connect. And we got a dotted line going through that vertex to represent that axis of symmetry. So you see here, that point is our vertex. I'm just reiterating. It's at -3, +4. Our x-intercepts, they're at -5, 0, and -1, 0. That's our y-intercept. It's at 0, -5. We know that our axis of symmetry, that equation is going to be x equals -3. Our domain is from -infinity to +infinity. Now our range, we're going in a different direction on this one. So our range, if you notice, we have to start here. And we're going to go downward, okay? So that's going to be our ending point. I said that backwards. This is where we're stopping. Keep in mind, in the interval notation, you write the smallest thing first. So everything negative has to come first. So it's going to go from -infinity, stopping at +4. And we put a bracket there. So make sure you know that you can't say 4 to -infinity. Your -infinity has to come first because it's smaller. And this will conclude 3.1.